During the later years of the Second World War, as the skies over Europe filled with the thunder of Allied bombers and escort fighters, few aircraft earned the level of fear and respect that surrounded the American P-51 Mustang. To many Luftwaffe pilots, the sight of its sleek fuselage and distinctive bubble canopy meant trouble. But for a small group of German test pilots and engineers, that fear eventually turned into fascination, because one day they finally got the chance to fly it for themselves. The story begins in 1944, a time when the balance of air power was shifting decisively in favor of the Allies. Germany's once dominant Luftwaffe was now struggling. Constant Allied bombing campaigns were targeting fuel supplies, factories, and transportation networks. The skies that once belonged to German fighters like the Bf 109 and the FW 190 were now contested, and increasingly they were being dominated by long-range American escorts. Those escorts were the P-51 Mustangs. The P-51 was not originally designed as the superfighter it became. In fact, it began as a British request to North American Aviation for a modern fighter to supplement the Royal Air Force. What they built exceeded every expectation. The combination of a sleek aerodynamic frame, a powerful Rolls-Royce Merlin engine, and incredible high-altitude performance turned the Mustang into one of the most effective aircraft of the entire war. By early 1944, German pilots had already learned to respect and fear the P-51. Its range allowed American bombers to be escorted deep into German airspace, even to Berlin. This meant Luftwaffe interceptors could no longer attack unprotected formations. Every time they climbed to meet the bombers, they found swarms of Mustangs waiting for them. The results were devastating for the Luftwaffe, but curiosity among German engineers and test pilots was growing. They wanted to understand why the Mustang was so good. They wanted to see what made it capable of outperforming many of their own aircraft. That opportunity arrived when several P-51s were captured intact after crash landings inside German-held territory. Instead of scrapping them, the Luftwaffe's Experimental and Evaluation Command, known as the Erprobungsstelle, began examining the planes closely. One of the first captured Mustangs was a P-51B, forced down in 1943 near the French coast. Later, other variants, including the more advanced P-51D, were recovered in usable condition. These aircraft were sent to the Luftwaffe's testing centers at Rechlin and later at East Stella in Göttingen, where elite test pilots examined every inch of the American design. When the German engineers began their analysis, they were immediately impressed by the craftsmanship and attention to detail. The Mustang's structure was not revolutionary. It was conventional in many ways, but its refinement was unmatched. Everything was optimized for aerodynamics and pilot efficiency. Its laminar-flow wing design, in particular, fascinated German aerodynamicists. This feature reduced drag dramatically, allowing the Mustang to fly faster and farther than expected, especially at high altitudes where many other fighters struggled. Test pilot Hans-Werner Lerche, one of the Luftwaffe's most experienced evaluators, was among the first to take a captured P-51 into the air. Lerche had already flown dozens of Allied aircraft, Spitfires, P-47s, and even Soviet Yak fighters, but the P-51 left a lasting impression. He later described the aircraft as a beautifully balanced machine with unusually stable handling. Even at high speeds, the Mustang's responsiveness and light control forces made it feel effortless to maneuver, especially in tight turns or when pulling out of dives. But perhaps the most surprising aspect was its engine performance. The British-built Rolls-Royce Merlin engine, produced under license by Packard in the United States, gave the P-51 superb high-altitude power. German pilots were astonished that an American-built version of a British engine could perform so flawlessly. At altitudes above 20,000 feet, where Luftwaffe engines like the Daimler-Benz DB605 or Junkers Umo 213 began to lose power, the Merlin kept delivering smooth, consistent thrust. That difference alone explained why the Mustang could escort bombers at such great heights, where German interceptors struggled to climb effectively. When German test reports were compiled, they were remarkably honest. The evaluators admitted that the P-51's performance exceeded expectations in nearly all flight conditions. They noted that its high-speed stability, roll rate, and acceleration were superior to most Luftwaffe fighters of the time. Even compared to the FW-190D or the late-model Bf-109G, the Mustang felt more balanced and easier to handle. The cockpit visibility, thanks to its clear bubble canopy, was another revelation, something German pilots long desired in their own fighters. Still, the Germans didn't only admire it, they studied it for practical reasons, too. Engineers at Messerschmitt and Focke-Wulf were constantly seeking ways to improve their aircraft designs. Some of the lessons learned from the Mustang's aerodynamics and cockpit layout were quietly applied to late-war projects, including the TI-152 and the Me-309 prototypes. Even though these planes never reached large-scale production, the influence was evident. By late 1944, Germany's fuel shortages and production issues made it nearly impossible to keep up with the pace of Allied innovation. Yet within the Luftwaffe testing divisions, flying the Mustang became a rare privilege, a chance to experience the enemy's best machine firsthand. Many pilots later admitted, often in post-war interviews, that they had developed a deep respect for the aircraft and its engineers. For them, flying the Mustang was like peering into the future of aviation. It represented everything Germany had once led in: precision engineering, aerodynamics, and long-range performance, but now perfected by their adversaries. One German pilot described the feeling as humbling, saying that for the first time, he realized just how far the balance of technology had shifted. The reports from these captured tests were never widely shared during the war. They remained within the closed circles of German aviation research, buried among hundreds of technical documents that would later fall into Allied hands after Germany's surrender. But their tone was unmistakable, a mix of admiration, envy, and quiet resignation. The Luftwaffe had encountered an aircraft it could not easily outmatch. And so, in the final months of the war, as Allied bombers continued to devastate German cities and factories, and as squadrons of Mustangs roamed the skies almost unchallenged, a small number of German pilots had an extraordinary realization. The P-51 Mustang wasn't just another enemy fighter. It was a masterpiece, and even they could not deny its brilliance. What they learned in those test flights would linger long after the war ended, influencing the design of future aircraft on both sides of the Atlantic. The captured Mustang had done more than prove itself in combat. It had silently earned the respect of those who once sought to destroy it. As German test pilots grew more familiar with the P-51 Mustang, their initial curiosity turned into a deeper technical fascination. The Luftwaffe's engineers began running detailed comparisons between the Mustang and their own frontline fighters, the Bf-109G, the Fu-190A and D, and even the advanced Me-262 jet. The goal wasn't simply admiration. It was understanding. Germany's air war was being lost in the skies, and they wanted to know why. At the Reckland Test Center, engineers conducted extensive aerodynamic studies. They analyzed the Mustang's laminar-flow wing, a relatively new design feature that delayed the onset of drag and turbulence at high speeds. German aircraft designers had heard of the concept, but had struggled to make it practical with their manufacturing techniques. When they examined the P-51's wing, they were struck by the precision of its construction. Every rivet, every seam was placed with meticulous accuracy. It was clear that American industrial capability had reached a level of consistency and quality that even Germany's famed engineers found difficult to match during wartime conditions. The Luftwaffe test pilots also praised the Mustang's flight stability at high altitudes. Many German aircraft were optimized for agility and climb rate, but at the cost of stability and range. The Mustang, by contrast, maintained balance and control even at speeds exceeding 400 miles per hour and altitudes above 25,000 feet. For escort missions, this meant less pilot fatigue and more efficient energy management. In combat, it meant a decisive edge in endurance and flexibility. One report from late 1944, written by an engineer at Göttingen, summarized it simply. This aircraft demonstrates a balance between power, control, and visibility that surpasses all known Luftwaffe designs. It is the first foreign fighter whose flight qualities inspire genuine admiration. This statement was remarkable considering the pride that German pilots had in their own machines. To them, the FW-190A had been the king of low-altitude dogfighting, and the Bf-109 had once ruled the skies over Europe. Yet now they were facing an aircraft that seemed to combine the best features of both, with few weaknesses. The cockpit layout of the Mustang was another source of surprise. German fighters were known for being mechanically advanced but ergonomically cramped. Levers, gauges, and switches were often scattered in awkward positions, forcing pilots to divide their attention between flying and managing the aircraft. The Mustang's cockpit, in contrast, was clean, logical, and pilot-friendly. Instruments were grouped efficiently, and visibility was extraordinary thanks to its bubble canopy. Luftwaffe pilots immediately noticed how much easier it was to track targets, spot threats, and maintain situational awareness, advantages that made all the difference in the chaos of aerial combat. German engineers noted how the Americans seemed to prioritize pilot comfort and control as much as raw performance. This was not a trivial matter. Fatigue was one of the biggest killers of fighter pilots during long missions. In the Mustang, however, pilots could fly for hours without feeling overwhelmed by vibrations, poor visibility, or engine strain. The P-51's smooth handling, combined with its excellent endurance, made it ideal for long escort missions, a role that no German fighter could effectively replicate. One of the most astonishing features for German evaluators was the Mustang's range. With its drop tanks, the aircraft could escort bombers from England all the way to Berlin and back, a feat that seemed almost impossible when the war began. In contrast, even the best German fighters had limited endurance, often forced to land after barely 2 hours of flight. This difference in range reshaped the entire strategic picture of the air war. It meant that Allied bombers could strike deeper targets without fear of being left unprotected. It also meant that German interceptors were constantly on the defensive, scrambling to meet attacks but unable to pursue their enemies beyond a limited radius. To understand this advantage, Luftwaffe analysts dissected the P-51's fuel system and engine efficiency. They found that the combination of the Merlin engine's supercharger and the aircraft's aerodynamic efficiency allowed for extraordinary fuel economy at cruising altitudes. In fact, the Mustang could fly over 1,600 kilometers on internal fuel alone, nearly double the range of most German fighters. For pilots like Hans-Werner Lerche, this realization was sobering. He later admitted that, "Our fighters could outclimb or outturn the Mustang briefly, but we could never stay in the fight as long as they could. They could choose when to engage and when to leave." Meanwhile, within German aircraft development circles, the lessons learned from these captured Mustangs began to influence ongoing projects. Engineers at Messerschmitt analyzed the P-51's wing for possible adaptation to the Me-209 and Me-309 experimental fighters. Focke-Wulf designers studied its radiator design and cooling system, which cleverly used heat from the coolant to produce a small amount of jet thrust, the so-called Meredith effect. This aerodynamic innovation was not widely understood in Germany until they examined the Mustang firsthand. The principle was elegant. By expelling heated air through a narrow vent, the aircraft gained a small amount of extra thrust, partially offsetting drag. German engineers realized that this clever design helped explain the Mustang's exceptional speed and range. But the admiration was not purely technical. There was also a psychological dimension to it. For German pilots who flew the P-51, the experience was bittersweet. They recognized that their enemy's industrial and engineering resources had surpassed their own. Many of them had entered the war believing that Germany led the world in aviation technology. Now, sitting in the cockpit of an American fighter that outperformed their best machines, they confronted a painful truth. Innovation had shifted westward. This realization spread quietly through Luftwaffe testing circles. Pilots like Lerche and Captain Karl Bauer noted that the Mustang felt effortless to fly, an airplane that did not punish its pilot for small mistakes. In combat terms, that meant more pilots could perform well in it. Where German fighters required skill and constant attention, the P-51 gave even average pilots the chance to fight effectively. This difference in usability was subtle but decisive. It explained, in part, why American squadrons were able to maintain such high success rates despite constant rotation of new recruits. The German pilots also noticed something else during their evaluations: the Mustang's reliability. Its Packard-built Merlin engines rarely suffered from the mechanical failures that plagued German engines late in the war. Fuel contamination, maintenance shortages, and overworked factories had taken a toll on Luftwaffe reliability. By contrast, the Mustang systems were robust, standardized, and easy to repair. Parts could be swapped between aircraft without modification. To German mechanics used to intricate hand-fitted components, this was nothing short of revolutionary. As the war dragged into its final phase, the Luftwaffe's testing facilities faced bombings, fuel shortages, and collapsing logistics. Yet even amid the chaos, engineers continued to study their captured Mustangs, documenting their findings in reports that would later astonish Allied intelligence teams. Many of those documents, recovered after the war, revealed that German engineers had rated the P-51 as the most balanced piston engine fighter of the conflict, not the fastest or the most heavily armed, but the best all-around machine. In one surviving report from 1945, a German analyst wrote, "This aircraft embodies the essence of total air superiority: speed, range, altitude, visibility, and dependability. It is a pilot's aircraft in every sense." By the time these evaluations were complete, the war was already nearing its end. The Allies had achieved overwhelming dominance in the air. Luftwaffe airfields were being bombed daily, and fuel supplies were running dry. But in those last desperate months, the German pilots who had flown the captured P-51s carried with them an unspoken respect. Even as they climbed into their own fighters for one more sortie, they knew, somewhere above them, Mustangs were already circling, engines humming steadily, guarding the bombers that would decide the fate of Europe. The captured P-51 had done more than impress them technically. It had shown them a reflection of what Germany once aspired to be: innovative, efficient, and unstoppable in the air. And as the Third Reich crumbled, that admiration, quiet, reluctant, but sincere, would become part of the legend of the Mustang's legacy. By early 1945, the skies above Europe were no longer a battleground. They were a one-sided domain of Allied power. The Luftwaffe, once the pride of Germany's military machine, was shattered. Its few remaining fighter units operated with limited fuel, inexperienced pilots, and little hope. Yet in the hidden corners of what was left of the Reich, German test pilots continued to study, record, and analyze one of the very machines that had helped seal their fate: the American P-51 Mustang. The captured Mustangs, painted with black crosses and marked with experimental codes, became symbols of irony inside the Luftwaffe's testing divisions. They were both trophies and teachers, enemy aircraft that revealed the future of aviation. The engineers who studied them knew the war was lost, but they also knew the science they were learning would outlive the conflict. When the Allies invaded Normandy in June 1944, the P-51 had already proven itself as the defining fighter of the war. Its long range allowed it to escort bombers deep into occupied territory. Its agility made it a formidable opponent in dogfights, and its firepower could tear through German aircraft with ruthless efficiency. But what impressed German analysts the most wasn't just what the Mustang did, it was how effortlessly it did it. In interviews conducted after the war, several German pilots spoke candidly about their impressions. Hans-Werner Lersche, who had flown nearly every major Allied aircraft captured by Germany, described the Mustang as an airplane that seems to anticipate the pilot's intentions. He noted that its controls remained light and predictable even during high-G maneuvers, something rare for piston engine fighters. Another test pilot, Hauptmann Karl Bauer, who had previously flown the Me-262 jet fighter, said that the Mustang possessed a level of harmony between engine, controls, and airframe that was unmatched among propeller-driven aircraft. To German engineers, this harmony was the product of industrial balance, a concept that had quietly eluded the Reich during the later years of the war. While German factories had produced technological marvels, jets, rockets, guided missiles, they lacked the ability to mass-produce reliable, standardized designs in the quantities that the Allies achieved. The P-51 symbolized that balance perfectly, an advanced yet practical fighter that could be built by the thousands, maintained easily and flown by pilots with only moderate training. By contrast, Germany's late-war fighters, the Me-262, the Tau-152, the Do-335, were sophisticated but fragile. They required scarce materials, meticulous assembly, and constant maintenance. The Mustang, on the other hand, seemed indestructible by comparison. It was simple to service, forgiving to fly, and capable of operating from rough airfields. When German mechanics examined its modular design, they found themselves marveling at how effortlessly it could be disassembled and repaired. This was a different philosophy, not the pursuit of perfection, but the mastery of practicality. As the war drew to its conclusion, several captured P-51s were destroyed during Allied bombings of German airfields. But a few survived long enough to be flown again, this time by Allied pilots who discovered the black crosses still painted on their fuselages. Ironically, some of the same aircraft that had once been tested by German hands now returned to Allied service, completing the full circle of wartime aviation. After the war, the surviving German reports on the P-51 fell into Allied possession. Among them were detailed evaluations of its flight characteristics, engine performance, and aerodynamic efficiency. American and British engineers were surprised by the level of detail and by the candid tone of respect within the documents. The Germans had not dismissed the aircraft as an enemy weapon. They had admired it as a masterpiece of design. In the years following 1945, this respect quietly shaped post-war aviation development. Many German engineers captured or recruited under Operation Paperclip brought with them deep, technical knowledge gained from evaluating Allied aircraft, including the P-51, the E. Lessons they learned from the Mustang's aerodynamics influenced early jet fighter development, particularly in wing shaping, control harmonization, and high-speed airflow design. In some ways, the Mustang's spirit, its balance of efficiency and elegance, lived on in the first generation of post-war jet fighters. For the men who had flown it during the war, the memory of the Mustang lingered for decades. In memoirs and post-war interviews, German pilots consistently placed the P-51 among the finest aircraft of the entire conflict. They admitted, often without hesitation, that it had played a decisive role in the Luftwaffe's defeat. One pilot remarked, "When the Mustangs came, the air war changed. They made the sky feel smaller for us." Another noted that the P-51 was the first enemy fighter we could not outlast or outrun. The combination of speed, range, and power meant that Luftwaffe pilots were constantly fighting on the defensive. Even the arrival of the Me-262 jet fighter, technologically superior on paper, could not reverse the trend. The jet's limited fuel, fragile engines, and lack of trained pilots made it a temporary advantage at best. The P-51, meanwhile, was everywhere, escorting bombers by day, strafing airfields by dusk, and hunting anything that moved across German territory. By 1945, the Luftwaffe's pilots understood that they were no longer the hunters. They were the hunted, and the Mustang was their most relentless pursuer. But for those few who flew it under controlled conditions, the experience was transformative. It was, as one of them put it, like shaking hands with the enemy and realizing he is an artist. The admiration was real, but it came too late. The Mustang's dominance was not only a triumph of engineering, it was a testament to strategy, production, and cooperation. The British had designed the engine that powered it. The Americans had built the airframe that carried it, and together they had produced a weapon that embodied the very unity Germany lacked. That unity, more than any single aircraft, ensured Allied victory. In the post-war years, as new jet technologies emerged, the P-51 remained in service across the world. It became a legend, flown by dozens of nations from Europe to Asia. Its sleek silhouette and unmistakable roar became symbols of a new era, one where air power defined global strength. For many German pilots who later joined NATO air forces, seeing the Mustang again, now as an Allies aircraft, stirred complex emotions. It was a reminder of defeat, but also of progress, proof that the pursuit of excellence in aviation had survived the war's destruction. The legacy of those captured Mustangs lives on in the countless stories told by the men who flew them. Their testimonies reveal not just admiration, but a deep respect born from understanding. They had faced the Mustang in combat, feared its presence, and in the end, learned from it. In doing so, they became part of its story, a story not of conquest, but of recognition. The P-51 Mustang remains, to this day, one of the greatest piston-engine fighters ever built. Its balance of speed, agility, endurance, and reliability made it the perfect weapon for its time. But its greatest achievement may not have been in the battles it fought. It was in the minds it changed. For when even the pilots of the Luftwaffe, proud heirs to a legacy of engineering genius, looked upon this American machine and called it superior, they were acknowledging something far greater than technology. They were acknowledging progress itself. And so, the story of the captured Mustang stands as a rare chapter in wartime history, one where admiration crossed enemy lines. The German pilots who flew it did not see an opponent's weapon. They saw the future of aviation. And as the war faded into history, the echoes of that admiration still lingered, a quiet, unspoken salute from one generation of pilots to another.